The year is 1958. 1 year ago, the Soviet Union launched the world's first satellite, Sputnik 1, into a stable orbit in outer space around the Earth. Sorry about that, it's something caught in my throat. The year is 1958. 1 year ago, the Soviet Union launched the world's first satellite, Sputnik 1, into a stable orbit in space around the Earth. The nuclear arms race between the Soviets and the Americans has quickly evolved into a missile race. Lacking the superior nuclear bomber capabilities of their competitors, the Soviets have moved their focus to ICBMs, long-range ballistic missiles that can reach their targets from thousands of miles away. Development of this technology, in turn, led to the use of orbital rockets for satellites that could perform communications and intelligence work. Following the Soviets' launch of a dog into orbit aboard Sputnik 2, it became clear to the Americans that the Soviets' goal was human spaceflight. In true American fashion, they needed to develop some competition to this. While spaceflight had previously been done under the guidance of the US Army, it was decided that NACA, the National Advisory Council of Aeronautics, would be replaced with a new civilian space program. NACA Director Hugh Dryden stated, quote, "It is of great urgency and importance to our country, both from consideration of our prestige as a nation, as well as military necessity, that this challenge be met by an energetic program of research and development for the conquest of space. It is accordingly proposed that the scientific research be the responsibility of a national civilian agency." On July 29, 1958, Eisenhower would sign the documents that birthed the agency we know today, the National Aeronautics and Space Administration. NASA began operations on October 1, 1958, with work already on the table. They absorbed the resources of NACA in its entirety, including their 3 major research laboratories, 2 small test facilities, its 8,000 employees, and its $100 million annual budget. Some elements of the Army Ballistic Missile Agency and the United States Naval Research Laboratory were also absorbed, and the agency was born with an active project that was already in the books. They had inherited the X-15 program from NACA, an experimental hypersonic rocket-powered aircraft that would go on to break world speed records as well as, technically, become the first spaceplane. Its highest flight reached an altitude of 107 kilometers, 7 kilometers above the arbitrary boundary where space begins. However, NASA had other plans that they began to get to work on quickly. Hugh Dryden, now a deputy for NASA's first administrator Keith Glennon, established the Space Task Group just 1 month into the agency's operations in November of 1958. A group of originally 45 engineers, secretaries, and computers, which was the term given to women tasked with performing calculations, the Space Task Group was put in charge of managing human spaceflight programs. Working quickly under the stress of the Cold War and the progress of the Soviet space program, the Space Task Group outlined the goals, requirements, and restrictions of their first program, officially put forth as Project Mercury. Originally named Project Astronaut, President Eisenhower felt this brought too much attention specifically to the pilot. Mercury was chosen instead from classical mythology, as this was already a trend for space rockets such as Atlas and Jupiter. The goals were as follows: place a crewed spacecraft around the Earth, investigate the pilot's ability to function in space, and recover the spacecraft and its crew safely. A set of existing rockets would be utilized as a launch vehicle for the spacecraft, which would be put together through a series of progressive tests. The requirements of Project Mercury added several more layers of challenges. Due to the rockets of the era being very unreliable, a launch escape system would be required, which would separate the spacecraft and its crew from the launch vehicle in the case of an impending failure. The Mercury launch escape system was developed by Grand Central Rocket Company, which later became the Lockheed Propulsion Company, and was a tall tower with a small solid rocket motor at the top. When the launch system detected an anomaly, the rocket would fire and the spacecraft would be pulled away from the failing rocket. Similar launch escape systems would continue to be used throughout history, and even to this day, despite the increasing reliability of the launch vehicles. Further requirements included an attitude control system so that the spacecraft could be reoriented, utilizing a series of monopropellant jets around the spacecraft's exterior that would fire to move it in the desired direction. A retro-rocket system would also be required, something that could fire in the opposite direction of the spacecraft's movement in order to slow it down and deorbit it. Finally, the craft would need a blunt body to be used for atmospheric re-entry. In order to return from orbit, a spacecraft needs to slow down and in a hurry. The best way to do this, it was found, was to use a craft that presented a large surface area for the incoming air to push against, which would in turn slow the spacecraft. 12 companies bid to build the Mercury spacecraft on a, at the time, $20 million contract. In January of 1959, the McDonnell Aircraft Corporation was chosen as the primary contractor, and North American Aviation was awarded with a contract to develop a small test rocket that would be used to develop the launch escape system. A number of different test sites were selected for launches. Crewed launches would be performed at the Atlantic Missile Range at Cape Canaveral Air Force Station in Florida, while smaller test launches would be done at Wallops Island in Virginia. Construction and improvement of a worldwide communications network using 16 tracking stations began in order to stay in contact with the spacecraft while it circled the planet. Resources from around the country and from every branch of the U.S. military were brought together to make Project Mercury operational, and entire towns near the test sites would begin to boom from an influx of jobs and tourism. The principal designer of the spacecraft was Maxime Fazet, who had started his work with the U.S. government during the time of NACA. He was the person to come up with the blunt body shape for atmospheric reentry, and would use this concept to come up with the general cone shape of the Mercury spacecraft. It was 10.8 feet tall and 6 feet wide, with 100 cubic feet of habitable volume, just large enough for a singular human occupant. Its exterior was made of a nickel alloy designed to withstand high temperatures, and inside were 120 controls, which consisted of 55 electrical switches, 30 fuses, and 35 mechanical levers. Its cone shape ended in a narrow neck which contained the recovery compartment, as well as the communications equipment, which would be jettisoned when the parachutes were deployed. At the bottom of the cone, a convex base carried the ablative heat shield. This was made up of an aluminum honeycomb covered with multiple layers of fiberglass, designed to absorb the heat of reentry while the outer surface chars and melts. At the same time, it lifts the hot shock layer gas away from the heat shield's outer wall and creates a cooler boundary layer for the spacecraft to pass through, minimizing damage to it. Below the heat shield were a pack of 2 sets of rockets that would be used first to separate the craft from its launch vehicle using posigrade rockets, and then fire a deorbit burn with retro-rockets. This pack would then be jettisoned, exposing the heat shield to the elements it was designed to endure. Between the heat shield and the inner wall of the capsule was a landing skirt, which would be deployed before landing, softening the blow of the splashdown. Inside, the astronaut would be strapped to a form-fitting seat with the instruments in front of him, oriented with his back facing the base of the vehicle, meant to reduce the effects of G-forces during re-entry. Beneath the seat was the environmental control system which supplied oxygen, heat, CO2 scrubbing, and collected the astronaut's urine on longer orbital flights. Near the astronaut's left hand was a manual abort handle, which would activate the launch escape system in the event that it failed to trigger automatically. The astronauts also wore a pressure suit with their own oxygen supply. The cabin had a pure oxygen environment that was chosen to save on spacecraft weight, as well as avoid the risk of decompression sickness. In the event of a fire, the cabin could be vented of all oxygen, and the astronaut could make an emergency return by relying on the oxygen in his pressure suit. He would also wear a number of instruments designed to monitor his health, which was another key element of the Mercury program. A number of decisions in designing the Mercury spacecraft were heavily influenced by the astronauts themselves. They took part in the development process, helping engineers to figure out the ideal placement of equipment and controls so that the astronauts could easily reach and work them. Their suits could be inflated or deflated, and they would usually fly deflated, but if they needed to be inflated, the astronauts would still need to be able to reach the most critical controls, such as the manual abort handle. The fact that the manual control system even existed was an astronaut decision, insisting that it was necessary for a pilot to be able to take control in the place of a communications failure. As the spacecraft had no onboard computer, all automatic controls were made by commands sent from the ground, and the astronauts didn't believe this could be solely relied upon. In order to complement the manual controls, they also insisted that the craft feature a window for orientation purposes. They were also able to look at a screen connected to a periscope that had a camera and could be turned 360 degrees around.
The astronauts have made a great many contributions to improve the effectiveness of Project Mercury. They work closely with the engineers. Each man is assigned to a particular phase of the program, such as communications, tracking, or the launch vehicle. He keeps his fellow astronauts informed on any changes or modifications.
The Mercury spacecraft design was modified 3 times by NASA between 1958 and 1959. Having initially selected the C design in November of 1958, a final configuration, D, was established after the C design failed a test flight in July of 1959. During the development of these various designs, work was being put into designing the heat shield. Experiments with ballistic missiles had shown that a blunt profile would create a shockwave that would send the majority of heat around the spacecraft, but one question remained as to how the shield itself would function. The first option was a heat sink, which utilizes a fluid medium such as air or liquid coolant to dissipate heat away from a device. A good example is the large piece of metal and fan that sit on top of your computer's central processing unit. The CPU generates a large amount of heat, which then passes into the metal heat sink and is expelled out by the fan. However, the choice was made instead to make the Mercury heat shield out of an ablative material, due to wind tunnel tests showing the difficulty of designing an aerodynamically sound heat sink. When design work began on the Mercury spacecraft, so did the astronauts' selection and training process. Prior to this, there had been no protocol for selecting astronauts, and Project Mercury would set the precedent. After closed-door discussions within the national government and open-door discussions with the public at large, the decision was made that NASA's first astronauts should all be qualified test pilots. Initially, there was an idea to make a widespread call for volunteers, bringing in thrill seekers such as rock climbers and acrobats. However, the idea was quickly shot down by NASA, who insisted that an undertaking such as spaceflight required individuals with professional training and education in flight engineering. By late 1958, coordination with President Eisenhower had narrowed the number of candidates down to 508. They then began to further whittle down this group by comparing their service records and finding the most skilled pilots of the group, stipulating requirements for age and height, and requiring that they hold at least one college degree in a STEM subject. During this time, one particular pilot was disqualified due to having left active military service in 1952. This made him a civilian pilot who is currently conducting test flights for the X-15 program. In 1962, he would become NASA's first civilian astronaut, by the name of Neil Armstrong. A number of other potential candidates ended up declining the proposal, believing that human spaceflight had no future beyond Project Mercury. Then Lieutenant Colonel Chuck Yeager, who was the first person to exceed the speed of sound, was disqualified due to not having a college degree, and Yeager would later become a vocal critic of Project Mercury, ridiculing the space program and labeling astronauts as spam in a can. Of the original group of 508, 110 candidates were selected for interviews. Of these 110, 32 were selected for further physical and mental testing. Their health, vision, hearing, as well as toleration to noise, vibrations, g-forces, personal isolation, and heat were all put to the test. They were placed in a special chamber and asked to perform tasks under conditions designed to make them feel confused and disoriented. They were made to answer a list of 500 questions about themselves and describe what they saw in different images. At the end of this long and complicated process, NASA had its first group of astronauts, dubbed the Mercury 7. Scott Carpenter, Gordon Cooper, John Glenn, Gus Grissom, Wally Schirra, Alan Shepard, and Deke Slayton. As a quick amusing aside, you may notice in this photo of the Mercury 7 that the front and center two astronauts have different boots than the others. This is because the boots for their actual suits weren't finished yet, and were told to simply spray paint their work boots. Scott Carpenter was a naval aviator, having flown a Lockheed P-2 Neptune on reconnaissance and anti-submarine missions along the coasts of the Soviet Union and China during the Korean War and in the Cold War. In 1954, he became a test pilot for the Navy, and in 1958 was named Air Intelligence Officer of the USS Hornet, then in dry dock. The following year, he would join Project Mercury, and afterwards would take a leave of absence to join the Navy's Sea Lab project, working with experimental deep-sea habitats. He retired from NASA in 1967, and from the Navy 2 years later. Gordon Cooper learned to fly as a child in his parents' biplane, and got his pilot's license at age 16. He joined the Marine Corps after high school to serve during World War II, but the war was over before he was able to do any overseas service. He then joined the Air Force, and served as a fighter pilot between 1949 and 1956, at which point he became a test pilot before being selected for Project Mercury in 1959. Afterwards, Cooper would remain with NASA until 1970, having served in the subsequent Project Gemini, as well as being a backup pilot for Apollo 10. When he retired, he would go on to serve on several corporate boards as a consultant for fields ranging from high-performance boat design to construction and aircraft design. John Glenn was a distinguished World War II fighter pilot, as well as serving during the Chinese Civil War and the Korean War, which awarded him 18 different air medals. In 1957, he made the world's first supersonic transcontinental flight across the United States in a Vought F-8 Crusader. He made this flight primarily due to boredom brought on by a desk job at the Navy Bureau of Aeronautics. This job did, however, give him access to spaceflight news, such as the X-15 rocket plane and the still-forming Project Mercury, information he absorbed intensely, becoming extremely interested in everything space-related. Joining Mercury made Glenn a resident expert due to his extensive flight experience, and was one of the most instrumental astronauts in terms of assisting with the Mercury spacecraft design. Glenn retired from NASA in 1964, was elected to Senate, and would later become the oldest person to enter Earth orbit when he flew aboard Space Shuttle Discovery at age 77. He was also the only person to fly in both the Mercury and the Space Shuttle program. Virgil Gus Grissom was also a World War II veteran, as well as serving in the Korean War. He earned his pilot's wings in 1951 and flew 100 combat missions during the latter war. After rotating home, he was assigned to work as a flight instructor for the Air Force, and then later as a test pilot at Wright-Patterson Air Force Base. He was selected for Project Mercury in 1959, and after his flight, would go on to do a second flight for Project Gemini. Sadly, Grissom would perish in the tragic Apollo 1 fire in 1967. Wally Schirra, like Grissom, was a veteran of both World War II and the Korean War, having flown 90 missions as a fighter pilot in the latter of the two. His father had been a World War I pilot, and Schirra would follow in his footsteps after the attack on Pearl Harbor in 1941 when he enrolled in the United States Naval Academy. He would be sent into the war 4 years later and spend its final months aboard the cruiser USS Alaska. Following Japan's surrender, he returned to the United States and received his naval aviator's wings in 1948. He was deployed on the carrier USS Midway at the outbreak of the Korean War, during which time he would transition from the Navy to the Air Force, flying an F-84 Thunderjet for the rest of his tour. After his time with Project Mercury, Schirra also flew on Gemini 6A, performing the first orbital rendezvous, and then command Apollo 7, the first crewed launch of the lunar program. He was the first astronaut to go into space 3 times, and the only astronaut to fly in the Mercury, Gemini, and Apollo programs. Alan Shepard was an exceptionally smart student, and when he graduated school a year early in 1940, he joined the Navy. He passed the entrance exam, but at age 16 was too young to enter, and was instead sent to a naval prep school. He graduated in the class of 1945 and was posted to the destroyer USS Cogswell. The next year, he would commence basic flight training in Texas. He struggled to learn, but took private lessons at a local civilian flight school to help him improve his skills. By 1947, his instructors rated him above average, and his naval aviator wings were pinned on his chest by his own father. By the time he was selected for Project Mercury, he was an instructor at a test pilot school in Rhode Island. After becoming the first American in space, Shepard was slated to be the first commander of a crewed Gemini mission, but was grounded after an inner ear disease diagnosis. He remained chief of the astronaut office for the duration of Project Gemini, and after being given a newly developed treatment for his illness, went on to fly Apollo 14 in 1971. Donald Kent Slayton, better known as Deke Slayton, flew in both the European and Pacific theaters during World War II, with 3 different aircraft. Afterwards, he enrolled at the University of Minnesota, finishing with a Bachelor of Science degree in Aeronautical Engineering. After briefly working for Boeing as an aeronautical engineer, he returned to military service for the Korean War, though saw little combat due to waiting for medical clearance regarding his eyesight. After the war, he went on to be a test pilot at Edwards Air Force Base in California, which led to his selection in Project Mercury, though he would be the only one in the program who never actually flew. Afterwards, he would take part in the iconic handshake between nations, the Apollo-Soyuz project, as well as be a key contributor to the development of the Space Shuttle program. He flew a T-38 chase plane alongside Space Shuttle Columbia during her second landing, and formally left NASA in 1982 with over 7,000 flight hours. They had the crew. They had the spacecraft. The astronauts had worked with the design team in order to optimize everything in preparation for real flight tests. The Mercury 7 went through a number of academic training programs to enhance their comprehension of the math behind the planned flights they were to undertake. They went through physical tests, from zero-G flights to simulations of high G forces and temperatures. The simulators ramped up the difficulty as they went on, preparing the astronauts for every possible scenario, every potential failure, every unlikely eccentricity.
On water impact, the pilot will normally sit back and wait to be picked up by helicopter or ship. However, in an emergency, if the craft is sinking or ventilation fouled, the pilot can climb out through the top. There's always the slight chance the spacecraft may land outside the designated area. The pilot is prepared and equipped to survive while waiting for the recovery teams to reach him. Training covers every conceivable eventuality, every emergency, no matter how unlikely it is to occur.
It was now time to begin real-world testing. First, obviously, would be uncrewed tests of the various systems of the Mercury spacecraft. A small solid-fueled booster called Little Joe was designed to loft the craft into the air in order to perform these tests, and its first flight, dubbed Little Joe 1, was to test the Mercury launch abort system during an ascent. On the 21st of August 1959, Project Mercury began 30 minutes ahead of schedule while the pad was still being evacuated. There was a flash of light and a burst of smoke, and once it had cleared, everyone realized that the spacecraft and abort system were gone. The abort system worked, perhaps better than expected. Project Mercury began prematurely on August 21, 1959, when the abort system of Little Joe 1 activated while the launch pad was still being evacuated. The rocket was carrying a boilerplate Mercury spacecraft, which is essentially a non-functional version of the craft that has all of the same physical characteristics of the final product. Boilerplates are used during testing to cut down on costs, as it's far less expensive to build a boilerplate than a full-scale functioning spacecraft and system. When the bright flash and loud boom of the abort system had faded away, the Mercury team was looking at a launch pad with an empty rocket and a lot of questions. An investigation into what had happened began quickly. Little Joe 1 was intended to be a max-Q abort, which is an abort performed during the portion of the launch that subjects the vehicle to the most intense amounts of aerodynamic pressure, but it ended early due to an issue that would be very popular during the early days of rocketry: transient voltages. Essentially an electrical leak, it was caused by a fault in a coil designed to protect biological specimens. Analysis showed the true fault to be the fact that the rapid abort system was wired directly into the destruct arming bus bar, which is a metallic bar used for high current power distribution. Batteries that had been shipped from England to the US were uncharged and shorted, and while they charged at the pad, they actuated the sequencer for the abort system. The abort system then sensed insufficient altitude and fired the abort motor. Due to the batteries not having reached a full charge, the escape tower didn't jettison, and the capsule didn't deploy its parachutes, causing both to crash into the sea and be destroyed. One might think that such a failure would effectively stall Project Mercury, but not in these early days. They were in a race against time, and, desperate to beat the Soviets, they kept going. While Little Joe 1 was prepared for a second attempt, the project moved on to Big Joe 1, intended to test the abilities of the spacecraft to re-enter the atmosphere and be recovered safely. Perhaps foreshadowing the rest of the mission, the Atlas 10D rocket was test-fired twice before the mission, and the first failed immediately. At T-0, the ignition stage delay timer commanded shutdown of the engines when, following the ignition of the small vernier engines on the side of the rocket, the main engine did not ignite. The second test firing, however, went according to plan, and the rocket was cleared for takeoff. Big Joe 1 lifted off from Cape Canaveral Launch Complex 14 on September 9, 1959. The flight was plagued with issues, beginning when the booster section failed to separate. Atlas was unique among two-stage rockets, in that the booster section consisted only of a skirt and engines, and after they dropped away, a sustainer engine would continue to fire and carry the rocket the rest of the way. When the booster section failed to separate on Big Joe 1, the sustainer engine was unable to increase the velocity as much as had been intended. The guidance system, relying on the vehicle's velocity to issue commands, resulted in the sustainer engine remaining firing until its oxidizer had depleted. Mission Control tried to shut down the second stage themselves, but because so much fuel had been spent, the valves that control the propellant flow couldn't be closed. As the sustainer engine sputtered and tried to relight, the Mercury spacecraft separated, and the residual thrust caused the rocket to bump into the craft several times. The ground control team kept firing the reaction control system thrusters to tear the capsule free of its malfunctioning rocket, and in doing so, exhausted the propellant and altered its already skewed trajectory. The boilerplate spacecraft flew to 140 kilometers or 87 miles in apogee and landed safely 800 kilometers or 500 miles away from where it was intended to. Despite the complications, the team was able to say that the craft's heat shield worked effectively and the capsule itself could withstand the stress of suborbital flight. However, Convair Division engineers regarded the flight as a failure due to the difficulties with the booster, and it was stated by many that the Atlas rocket was far from being ready to support a crewed launch. Following this, Little Joe 6 was readied, which had the same intentions of testing the abort system as Little Joe 1. Launched on October 4, 1959 from Wallops Island, this test flew to an apogee of 60 kilometers and lasted 5 minutes 10 seconds. While there's very little detail about the progression of this test, NASA lists it as a partial success, though it isn't clear what failed to make it partial. I've speculated that the metal chevron plates used as a heat reflector shield failed, as one article references that these kept shattering and were only used on Little Joe 6 as well as on the next test. 2 more Little Joe tests as well as one on-the-pad abort test followed, further refining the design of the abort system. In the middle of these tests, mercury-atlas 1 was launched to again test the rocket and spacecraft combination, but failed just under 1 minute after liftoff. Because the day was rainy and overcast, the booster was out of visual range once it passed above the clouds, and all telemetry data from the vehicle suddenly ceased as it passed through max Q. As the Atlas rocket was clearly far from ready, the next step of the program was to qualify the combination of a Mercury spacecraft with a Redstone missile, intending to perform the first suborbital flights with a finished Mercury spacecraft. We are now in November of 1960, as we arrive at the launch of Mercury-Redstone 1 on November 21st, and what might be the single most visually comical launch failure in the history of aerospace. Mercury-Redstone 1 was intended to qualify the full Mercury spacecraft as well as qualify the automated systems that controlled the launch and recovery. The launch site was Cape Canaveral Air Force Station Launch Complex 5, and after a first attempt was scrubbed due to poor weather, the rocket was finally ready for liftoff on November 21st at 9 a.m. Eastern Standard Time. Following a perfectly normal countdown, this happened. All in all, the rocket traveled approximately 4 inches before the engine shut down and it settled back onto the pad. Following this, the escape rocket, believing that the flight had been completed, jettisoned itself, leaving the capsule behind. A few seconds later, the capsule, detecting that it was below 10,000 feet, deployed its parachutes, which uselessly fell to one side. Following this, alarms began to sound at the launch complex, and panic ensued. There was now a fully fueled rocket, under its own power, sitting on the launch pad, with absolutely nothing securing it, and nobody knew what to do. Everyone began to scramble, and ideas were thrown around. The rocket itself was not the only concern. The capsule had a retro rocket package that could, at any moment, decide to fire, adding a volatile propellant to the mix of everything currently on the pad. There was also the range safety destruct charges, meant to be used in the case of a failure mid-flight. Any detonation on the pad would also detonate those charges, adding an extra explosive power to the mix. The parachutes were also a problem. They were hanging off the side of the rocket, and a strong enough wind gust could cause them to pull the entire rocket over onto its side. Thankfully, weather conditions prevented this from happening, but the panic control room still had a problem to solve. The launch team had several ideas, all of which were shot down by Flight Director Chris Kraft. One idea went so far as to suggest using a rifle to shoot holes in the booster's propellant tanks and depressurize them. Kraft quickly said no. By the end of all the discussions, a decision was made, and the first rule of flight control became a thing. If you don't know what to do, don't do anything, Kraft said as the decision was made to wait out the battery's discharge and let the oxidizer boil off. The Redstone rocket, like many others, used cryogenic fuels, meaning they need to be stored at supercool temperatures in order to maintain their liquid state. This is why most rockets are only fueled mere hours before liftoff, because the fuel will begin to boil off when it meets the higher temperatures of the launch site. So the decision was made to simply let that happen. Wait until the batteries in the rocket and the capsule ran down, and the liquid oxygen in the tank boils off in a gaseous form. The next morning, the rocket was functionally dead, and the team was able to begin disassembling and dissecting the failed system. Investigations revealed that the engine shutdown was caused by 2 electrical cables separating in the wrong order. The control cable was supposed to separate first, but it was longer than expected, being a cable designed for a military Redstone missile rather than the shorter one designed for Mercury Redstone. The control cable separated just 29 milliseconds after the power cable separated, and this confusion led to an electrical surge through a relay that triggered the engine cutoff command. When the capsule received this cutoff command, the abort tower, believing the powered flight phase had been completed, jettisoned. Normally, the capsule would wait to separate itself from the booster until the vehicle had almost stopped accelerating to prevent the booster and the spacecraft from colliding. However, because the Redstone missile was not moving, the capsule read a constant acceleration of 1g, and the capsule separation never occurred. Once the escape rocket jettisoned, the capsule entered recovery mode, preparing for a landing that it didn't realize had already happened. Immediately realizing that the capsule was below 10,000 feet, the parachute deployment began. The drogue chute deployed first, carrying the capsule's antenna system with it, followed by the main parachute. The capsule then detected that the main parachute was not supporting the weight of the capsule, in fact it was hanging idly beside it, so it believed that the main parachute had failed and deployed the reserve parachute. The Redstone rocket had suffered minor damage when it fell back onto the pad, but it was believed it could be refurbished and used again, so it was returned to Marshall Space Flight Center and was held in reserve. It would in fact never fly again, and would eventually be put on display at the Space Orientation Center of Marshall Space Flight Center. The Mercury spacecraft, however, was completely undamaged, so it would in fact be reused for another flight. The next flight, in fact. But that's something for the next episode. Project Mercury had stumbled yet again. The spacecraft was ready, or at least appeared to be ready, but the Atlas and Redstone rockets were not. It was time to go back to the drawing board, fix the launch systems, and try again. Project Mercury stumbled, but never fell down. The race was far from over.
December 19. MR1 is ready to go again. Launch is only seconds away. The flight control director is ready to take over. Radar and telemetry equipment is ready. This is another test in the pyramid of testing. Flight test, another step toward man in space.
Following the spectacular failure at liftoff that was Mercury-Redstone 1, otherwise known as the 4-inch flight, NASA was not about to lose any steam in their first crewed space program. That flight had failed due to an extremely simple and easy-to-fix issue. The wrong power cable had been installed on the Redstone booster. So NASA quickly got to work, refurbished the Mercury spacecraft, fetched an all-new Redstone booster, quadruple-checked the cabling, and prepared for Mercury-Redstone 1A, a full repeat of the previous flight's goals. The first true spaceflight of Project Mercury went off without a hitch on December 19, 1960, from Launch Complex 5 at Cape Canaveral, Florida. Mercury-Redstone 1A was intended to be a full, uncrewed spaceflight of a finished Mercury spacecraft, testing its instrumentation, posigrade rockets, retro rockets, and recovery system. Lifting off flawlessly, the rocket carried the spacecraft to an altitude of 210 or 130 miles, which traveled a grand total distance of 378 kilometers or 235 miles. The mission was a complete success, and it was time to move on to crewed flights. Or rather, a form of crew.
7 United States Project Mercury astronauts are among the observers at the firing of a Redstone rocket, carrying an unmanned space capsule. The capsule, called the MR-1A, is an exact replica of what will be America's first man-in-space capsule. After the flawless launching, the carrier rocket heads down the Atlantic firing range until it burns out and separates from the capsule, which travels 135 miles further out into space before returning to Earth. The re-entry is as flawless as the launching. It's the first wholly successful test in the Project Mercury series. The entire sequence in space took 16 minutes from blastoff. Scientists reported that everything went exactly as planned. The capsule, which carried some of the most complex instruments involved in any United States space shot to date, returned in fine shape. Good news for the astronauts, one of whom will stake his life on its performance sometime in 1961.
Sometime in July of 1957, a common chimpanzee was born in French Cameroon. He was quickly captured by animal trappers and sent to the rare bird farm in Miami, Florida. He was named Ham. 2 years after he was born, Ham was purchased by the United States Air Force and brought to Holloman Air Force Base in New Mexico. He became part of a group of 40 chimpanzee flight candidates, and after evaluation was one of 18, then 6. Ham was trained under the direction of neuroscientist Joseph V. Brady to perform simple timed tasks in response to electric lights and sounds. At one point, he was taught to push a lever within 5 seconds of seeing a flashing blue light. Failure to do so would result in an application of a, quote, light electric shock to his feet, while a correct response earned him a banana pellet. Ham was, of course, most likely unaware that he was being trained to be a substitute human on a spaceflight. Chimpanzees share many qualities with humans that make them ideal candidates, such as a similar placement of the organs within the body and a similar reaction time to outside stimulus. With a chimp, they would have a better idea about how well a human pilot might react to a sudden emergency during a spaceflight. With Ham, they had their test subject. Of his 18 months of training, 3 weeks were spent in a Mercury simulator. At this time, Ham was still one of 6 chimps who could have been chosen, and while the competition was fierce, Ham was deemed, quote, full of energy and good humor, and would quickly become the most liked candidate. On January 31st, 1961, the 3.5-year-old chimpanzee was prepared for his mission. He was inserted into Mercury spacecraft number 5 several hours before the liftoff of Mercury-Redstone 2. This spacecraft had 6 all-new systems: an environmental control system, attitude stabilization control system, live retro rockets, though I'm not sure exactly what that means. My best guess is that they could be activated manually, a voice communication system, an abort sensing system, and a pneumatic landing bag.
In McDonald's surgically clean white room, the MR2 craft nears completion. Electronic systems to control automatic equipment in the craft after separation from the booster must be checked and rechecked. The retrograde rockets will be tested in space. The antenna housing will transmit telemetry. The heat shield must be inspected carefully before attachment to the craft. The Mercury craft and its Redstone meet at the launch pad. The pre-planned flight path for MR2 defines a ballistic trajectory 254 miles downrange from launch to touchdown. The spacecraft is to reach a maximum altitude of 120 statute miles. The chimp is to undergo about 4.5 minutes of weightlessness. The first United States astronaut will take the same ride, in the same van, out to the same launch pad, and up the same elevator to the top of the rocket and into the Mercury spacecraft, just as Ham is doing today.
After several delays, Mercury-Redstone 2 was ready to lift off.
4, 3, 2, 1, 0. Fire, liftoff. And Ham is on his way.
1 minute into the flight, telemetry data showed that the flight path angle was too high and rising, and soon after, it was predicting a maximum acceleration of 17 Gs, too high for any chimp or human to handle. At 2 minutes 17 seconds, the booster's liquid oxygen depleted, and this change in chamber pressure was sensed by the new closed-loop abort system. The escape tower fired and carried the spacecraft upwards. Because of both the high flight angle and the boost from the escape tower, the spacecraft reached an unintended apogee of 253 kilometers, or 157 miles. In addition, the retro rockets were jettisoned during the abort, so the spacecraft would have to face atmospheric re-entry at the highest possible speeds. Another problem occurred shortly after the abort. The cabin pressure dropped down to about 7 kilopascals, or 1 pound per square inch. The capsule was effectively exposed to the outside environment. Ham, however, was safe in a couch spacesuit that had its own environmental systems, the pressure within it remaining normal, as well as the temperature staying well within the optimum range. At T+5 minutes, Ham reached his apogee high above the Earth. He seemed completely unaffected as he continued performing his tasks of pushing buttons and pulling levers, and around him, a surprising amount of dust and debris floated around in the capsule.
Ham is weightless in a world of zero gravity and will be for 5 full minutes. He appears not to be affected at all as he carries out his assigned tasks.
The various problems during ascent resulted in re-entry and splashdown occurring out of visual range of the recovery forces at about T+16 minutes. By the time the recovery teams arrived, they found the spacecraft on its side, taking on water and sinking into the ocean. Upon splashdown, the heat shield had bounced against the bottom of the capsule, punching holes into the bulkhead. The craft also had a snorkel valve on it, and capsizing had caused this open valve to let more water spill into the capsule. The helicopters picked up the capsule with about 800 pounds of water within it, and lowered it onto the deck of the USS Donner.
But bring it back. Put it on deck. Bring the crew out to open the hatch and remove the couch. And be aware, the spacecraft traveled 40 miles higher and 120 miles farther than scheduled. The engine shut down a fraction of a second sooner than programmed. The abort system worked, but Ham sustained 18 G instead of the normal 11 that was expected.
When the hatch was opened, they found Ham safe and sound, and seemingly in good spirits. Once his spacesuit was opened, he was photographed gleefully accepting his reward for this daring mission, an apple and half of an orange. And it is only at this point will I reveal that Ham was only given the name Ham after he had been recovered. Until that point, just in case, he had been known simply as Number 65. Mercury-Redstone 2 is a flight that can be properly deemed a partial success. On one hand, the Mercury-Redstone launch vehicle was deemed to not yet be safe enough for a nominal human spaceflight. On the other hand, despite a number of failures during ascent and splashdown, Ham came home alive and unharmed. More work clearly needed to be done, But there was nothing about this flight that necessitated halting Project Mercury. Instead, they went to work on mercury-redstone BD, standing for booster development, and while they did, Ham was retired to a national zoo in Washington, D.C. Ham went on to live for another 17 years, despite suffering from chronic heart disease and liver disease that were unrelated to his spaceflight. On January 19th of 1983, Ham the chimpanzee, the first great ape in outer space, passed away. There was a brief discussion about taxidermying and displaying him at the Smithsonian, much like the Soviet space dogs Belka and Strelka. The public didn't care for this idea, and honestly, neither do I, so instead, Ham's skeleton is held in the collection of the National Museum of Health and Medicine, and the rest of his remains were buried at the International Space Hall of Fame. I think about Ham sometimes, and wonder how much he understood about the mission he had performed. I sometimes imagine a scenario, and even considered writing a novel about it, in which Ham spent weeks or more trying to explain to the other chimps in the sanctuary that the Earth is a sphere in outer space, and the humans had sent him to go see it. Maybe I'm a little optimistic. Maybe not. NASA was currently of the opinion that the Redstone booster needed further development, and Dr. Wernher von Braun added mercury-redstone BD to the launch schedule in between MR2 and MR3. This was met with heavy protests, especially by astronaut Alan Shepard, who was scheduled for MR3. He argued that the problems with the booster had been readily identified and easily fixed, but von Braun was of the opinion that a crude test could only occur following a perfect test flight, and the Redstone's performance on MR1A and MR2 had not met acceptable standards, despite NASA's own documents citing MR1A as a complete success. The cause of the previous rocket's overaccelerations was a servo valve that was poorly regulating the flow of hydrogen peroxide to the steam generator, which overpowered the fuel pumps. Modifications to the thrust regulator and velocity integrator ensured that the engines wouldn't be able to exceed their limited speeds. Additionally, engine cutoff would no longer signal an abort and thereby stop the inadvertent escape tower firing as it did on MR2. The overall rocket was also given further rigidity via stiffeners installed in the ballast section, as well as insulation applied to the instrument compartment. Mated to a boilerplate spacecraft with an inert abort tower and no posigrade or retrograde rockets, Mercury BD launched to an apogee of 182 kilometers or 113 miles, and its ascent was again a perfect success. As this was its only goal, it was never fitted with a separation system, and both the spacecraft and rocket crashed into the ocean 5 miles short of the intended splashdown zone. In a somewhat amusing twist, this lack of separation led to a false rumor beginning to spread in the USSR. Nikolai Kamenin, head of the Soviet Cosmonaut Office, wrote in his journal that, quote, "On March 24, they had a big failure. Capsule Mercury failed to separate from the carrier and sank into the ocean." It's possible that this misjudgment may have spurred the Soviets on, as by the end of the year, they would launch the first human being into space. However, only 3 weeks later, NASA would do the same. We are now at the starting line of the space race. On April 12, 1961, the Soviet Union took an early lead in the space race when they launched Vostok 1, sending cosmonaut Yuri Gagarin into a single orbit around the Earth. The first man in space was a major milestone, of course, but NASA wasn't to be so easily bested. After concerns about the safety of the Redstone booster had been voiced after the numerous issues that occurred on Mercury-Redstone 2, more time was allocated to solve these issues before flying a human being. By late February, there were still 7 major alterations being made to the booster which would require testing. Mercury-Redstone BD, an unmanned booster development flight, was added to the schedule for March 28th, pushing the launch of the crewed Mercury-Redstone 3 an entire month back to April 25th. It can be argued that Wernher von Braun's insistence on adding a booster development flight is one reason NASA lost this first milestone of the race to the Soviets. The USSR was in a time of celebration, and while the United States quietly congratulated their competitors, they continued preparation for Mercury-Redstone 3. Alan Shepard, chosen for the flight months earlier, named his Mercury spacecraft Freedom 7, setting a precedent for the other astronauts to name theirs as well, all ending with 7 in reference to the group they were a part of, the Mercury 7. Shepard's spacecraft had arrived at Cape Canaveral in early December of 1960, but ended up requiring a lot of development and testing work before it was deemed safe for flight. The booster intended to carry Freedom 7 had also been delivered in December, but after the failure of Mercury-Redstone 1, the booster was swapped out to be used on Mercury-Redstone 1A. The replacement booster didn't arrive at the Cape until late March of 1961, and by this time, the booster development test had already pushed back the launch date. The first launch attempt of Freedom 7 ended up being on May 2nd. The pride of the United States had taken a hit by being 3 weeks late, but the rocket was ready and Shepard was ready. The weather, however, was not ready. In what continues to be a boundless problem for rocket launches even today, Freedom 7 was cancelled 2 hours and 20 minutes before launch time, while Shepard was in his suit and sitting in a nearby hangar. No bother. Rescheduled for May 5th. Slow and steady wins the race. Or rather, in the case of spaceflight, safe and steady. Alan Bartlett Shepard Jr. was born on November 18, 1923, at 64 Hampstead Road in Derry, New Hampshire. His father, Alan Bartlett Shepard Sr., known as Bart, joined the National Guard in 1915 and served in France with the American Expeditionary Force during World War I. This military family history would rub off on Shepard Jr., who was an exceptional student at Adams School in Derry. He skipped the 6th grade and was also a first-class Boy Scout in the Boy Scouts of America. In 1936, Shepard attended Pinkerton Academy, a private school that his father had also attended, and completed grades 9 to 12 there. Around this time, Shepard became fascinated with flight and created a model airplane club at Pinkerton. His Christmas present in 1938 was a flight in a Douglas DC-3. The following year, he would begin cycling to Manchester Airfield, where he would do odd jobs in exchange for the occasional ride in an airplane or an informal flying lesson. By the time Shepard graduated from Pinkerton in 1940, World War II was raging in Europe, and his father wanted him to join the Army. Shepard instead chose the Navy, and passed the entrance exam to the Naval Academy at Annapolis in the same year. However, being age 16, Shepard was too young to enter, and was sent instead to the Admiral Farragut Academy, a Navy prep school. He graduated the next year, and tests administered by the Academy indicated Shepard had an IQ of around 145, although his grades were unimpressive. Perhaps he was distracted by thoughts of flying planes. Nevertheless, he graduated with the class of 1945 in June of 1944, in fact on the same day that the Normandy landings occurred in France. Shepard was posted to the destroyer USS Cogswell after a month of instruction in aviation and helped rescue 172 sailors from the cruiser USS Reno after it took Japanese torpedo fire. Later that year, Cogswell would be buffeted by Typhoon Cobra, which sunk 3 other destroyers, and battled kamikaze pilots in the invasion of Lingayen Gulf. During a return to the U.S. for an overhaul, Shepard spent his 3 weeks' leave marrying Louise Brewer, whom he met at Annapolis. He rejoined Cogswell for the end of the war, participating in the Battle of Okinawa, and being present in Tokyo Bay when Japan surrendered in September of 1945. Returning to the United States, Shepard commenced basic flight training at Naval Air Station Corpus Christi in January of 1946. He was not the most skilled pilot. In fact, for a time he was facing being dropped and reassigned to the Surface Navy. He began taking private flying lessons at a local civilian flying school, which the Navy frowned upon, and earned a civil pilot's license. His flying skills improved until he was rated above average by instructors in the next year, and was transferred to Naval Air Station Pensacola for advanced training. He received his naval aviator wings after a final test of 6 perfect landings on the light aircraft carrier USS Saipan. His wings were pinned to his chest by his own father. After 3 years of service with Fighter Squadron 42, Shepard was selected to attend the United States Naval Test Pilot School in Maryland. In his time there, he would conduct high-altitude tests, was given certification for the McDonnell F-2H Banshee, and performed tests of the angled flight deck. He flight tested half a dozen other experimental aircraft after the end of the Korean War, nearly perished in a high-speed dive in a Grumman F-11, and became an aircraft readiness officer by 1957, having logged more than 3,600 hours of flight time. The newly formed NASA recruited Shepard from a group of 110 candidates who matched the minimum standard for Project Mercury: be younger than 40, possess a bachelor's degree or equivalent, and be 5'11" or shorter. After the first round of testing, 110 had been reduced to 32, which was more than NASA had expected anyway. They whittled down the remaining candidates through grueling physical and psychological tests at the Lovelace Clinic in the Wright Aerospace Medical Laboratory. During this process, one particular candidate would be rejected on medical grounds, but this diagnosis was later found to be an error, and James Lovell would later rejoin NASA to become a key player during Project Apollo. Having intended to choose only 6 candidates, Robert Gilruth, director of the NASA Space Task Group, found himself unable to choose, and instead settled for 7. At this point, the astronauts were in something of a competition for who would fly the first crewed Mercury mission, and Shepard in particular was in direct competition with John Glenn. As a result, Shepard quit smoking and copied Glenn's habit of making a morning jog. On January 19, 1961, the astronauts were informed that Shepard would be the first astronaut to fly. He began his final training and preparation while the flight of Freedom 7 was repeatedly pushed back. When he learned that Yuri Gagarin had become the first person in space, Shepard reportedly slammed his fist down on a table so hard that a NASA public relations officer believed he might have broken his hand. Nevertheless, after all the delays, failures, further testing, and even further delays, Mercury-Redstone 3 was on the pad. Freedom 7 was ready to launch. The countdown began at 8:30 p.m. the previous night, and Alan Shepard woke up and consumed a hearty breakfast of steak and eggs with toast, coffee, and orange juice. He got into his suit and was checked over, and entered the spacecraft at 5:15 a.m., just over 2 hours before launch time of 7:20. At 7:05, the launch was held for an hour to let cloud cover clear, as well as to fix a power supply unit. Shortly after the count restarted, it was paused again in order to reboot a computer at Goddard Space Flight Center. After just over 2.5 hours of unplanned holds, the count resumed once more. Coming into the final count, Shepard announced he had a serious problem, one that nobody had a contingency for, and was completely unplanned for. Alan Shepard had to pee. Because the trip to space was going to last just under 20 minutes, nobody had thought to equip the Mercury spacecraft or the spacesuit with any form of waste collection device. However, after so many delays, Shepard had been sitting in the spacecraft for 3 hours with his morning coffee and orange juice collecting in his bladder. When he told the blockhouse crew of his severe need to urinate, they replied that it was impossible. They would have to set the White Room back up and waste considerable amounts of time removing the heavily bolted hatch of the spacecraft. Shepard responded with an ultimatum. "If I can't get out and go, I'll just go." "You can't do that," the blockhouse protested. "You'll short out the medical electrodes you've got on your body." In perhaps the ultimate example of when you gotta go, Shepard told them to turn the electrodes' power off. Shepard proceeded to finally relieve himself, and because he was seated with his back facing downward, the urine pooled beneath his back, and with the oxygen flowing through the spacesuit, he soon dried out. The countdown was resumed for the final time.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
All right, liftoff, and the clock is started. Yes, sir. Reading loud and clear. I tell you.
Freedom 7 finally blasted off of the pad at 9:34 a.m. Eastern Standard Time, watched by an estimated 45 million television viewers. After all of the testing and modifications, the Redstone booster performed admirably, subjecting Shepard to a maximum acceleration of 6.3 Gs before the engine shut down just under 2.5 minutes into the launch.
Freedom 7 is still go.
Freedom 7 is still go. The trajectory is A-OK.
This is 7. Fuel is go. 1.8 G. 8 PSI cabin, and the oxygen is go.
Freedom 7 reports the mission is still A-OK. Full go.
Cabin pressure is holding at 5.5. Cabin holding at 5.5.
Freedom 7 in voice communication with the Mercury Control Center.
Fuel is go. 2.5 G.
Reports
Cabin
3.5 G.
5.5.
Cabin pressure holding
Oxygen
5.
is go. The main bus is 24.
Cabin pressure holding 5.5
Isolated
pounds
battery
per
is
square inch.
29.
Right, read you 5 to 5, protect the right, okay.
Okay, it's a lot smoother now, a lot smoother.
Roger.
The flight trajectory is still A-OK. The pilot is in good voice communication with Mercury Control.
7 here, fuel is go, 4G, 5.5 cabin, oxygen go, all systems are go.
Freedom 7 with astronaut Alan B. Shepard reports the fuel system is go, 4G,
5G,
cabin 5.5 pounds per square inch, oxygen go, all systems go.
cut off, tower jettison green.
The escape tower jettisoned, and Freedom 7 was separated from the booster with detonation of the explosive bolts that joined the two together. The spacecraft then fired its posigrade rockets to gain distance, and the automated attitude control system kept the capsule steady as it ascended, and then spun it around for the correct orientation to re-enter the atmosphere. The ascent was complete, and Alan Shepard was the first American in space.
Orbital attitude.
SCS is okay. Control movements.
He's going to hand control movements now.
At this point, Shepard was free to put his hands on the controls, testing the spacecraft's orientation systems. For redundancy purposes, the thrusters that Shepard controlled were different from the ones that the automated system used and had its own fuel supply. Shepard used a 3-axis control stick that would proportionally open the valves for the thrusters, so if he moved a bit, the spacecraft moved a bit, and if he moved a lot, the spacecraft moved a lot. He could also switch off individual axes of movement, and in fact he obtained manual control one axis at a time, testing each before switching on the next. First he took control of pitch, reorienting the spacecraft nose down, then returning to the previous attitude. Next, yaw. He moved the spacecraft to the left, and then to the right until it was back in line. Finally, roll. He tilted the spacecraft on its longitudinal axis a few degrees and then back. He reported back that the control felt almost identical to the Mercury simulator. However, on Earth, Shepard could hear the jets firing, and this helped him with orienting himself. In reality, there was so much background noise that Shepard couldn't hear the jets. Next, Shepard prepared for a new task, observations of the ground from the spacecraft's periscope, which extended through the bottom of the hull beneath his feet. While waiting on the launch pad, Shepard had inserted a medium gray filter into the periscope to cut down on sun glare. He hadn't had time to remove it before launch, and when he tried to now, the wrist of his spacesuit bumped the handle by his left hand that would activate the launch escape system. Even though the escape tower was long gone at this point, Shepard was concerned for any effect this might have on the craft if it was activated, and gave up trying to remove the filter. Although the filter washed out the colors, Shepard was easily able to distinguish land masses from clouds and water. He reported seeing the coast of Florida, Lake Okeechobee, and Andros Island in the Bahamas.
On the periscope, what a beautiful view.
What a beautiful view.
Cloud cover over in Florida, 3 to 4 tenths near the eastern coast, obscures up through Hatteras. You can see Okeechobee, identify Andros
3
Island,
to 4 tenths cloud cover
identify
along
the
the
reef.
eastern coast of the United States.
As the spacecraft reached its apogee, a light turned on in the cabin, catching Shepard's attention. Start retro sequence. This indicated that the retro rockets were about to fire in sequence. Shepard checked his attitude indicator and realized that while he was looking at the Earth, the spacecraft had drifted somewhat in pitch. He quickly attempted to move it to the correct retro fire attitude, but was just shy of it before the first rocket fired. Thankfully, this didn't affect very much, shifting his landing location by a completely insignificant amount.
All is smooth.
Pilot reports mission very smooth.
You notice Retro 1,
Retro rocket number 1 has fired.
very smooth. Retro 2,
Retro number 2 has fired.
Retro 3,
Retro number 3 has fired.
all 3 retros are fired. Okay, 3 retros have fired. Retro jettison is back to arm.
After retro fire, the rocket pack on the base of the spacecraft was jettisoned. It was attached to the heat shield by straps, and Shepard heard a thump and saw one of the straps fly past a window, but the confirmation light didn't turn on. The capsule communicator, or Capcom, on the ground, fellow astronaut Deke Slayton, confirmed to Shepard that the rocket pack was indeed gone, so Shepard manually activated the confirmation light. After the automatic system brought him to re-entry orientation, Shepard took over and held manual control during the majority of the re-entry, experiencing 11.6 Gs until the capsule stabilized, at which point he relinquished control to the automated system again. The craft descended faster than anticipated, but the drogue parachute deployed safely anyway, at 6.4 kilometers or 21,000 feet, followed by the main parachute at 3 kilometers or 10,000 feet. Freedom 7 splashed down with an impact that was comparable to a jet aircraft touching down on the flight deck of an aircraft carrier, tilted over on its right side, and then gently righted itself after a minute. Shepard calmly reported that he had landed safely and was ready to be recovered. The recovery helicopter arrived a few minutes later, and after struggling with the spacecraft's antenna, the capsule was lifted far enough for Shepard to open the main hatch and into a waiting sling hoist. He was pulled into the helicopter, and he and the capsule were carried to the waiting USS Lake Champlain, an aircraft carrier. The entire process took 11 minutes from splashdown to boarding the carrier, and the flight itself had lasted 15 minutes and 22 seconds. Freedom 7 reached an apogee of 187 kilometers, or 116 miles, and a maximum speed of 8,340 kilometers an hour, or 5,180 miles per hour. Examination after the fact revealed that the spacecraft was in excellent shape, and engineers stated that it could have been safely used again in another launch after some minor refurbishment. It would instead be displayed at various museums, libraries, and naval academies around the world. Currently, it is on display at the Smithsonian National Air and Space Museum in Washington, D.C. Alan Shepard Jr., now an American hero, received the NASA Distinguished Service Medal from President John F. Kennedy, the second person to ever receive one. He was also awarded the Distinguished Flying Cross from the Navy. He was far from finished his work with NASA. His name would continue to pop up in these NASA program documentaries, at least until the point where he becomes the 5th and oldest person to walk on the surface of the moon. Project Mercury was officially underway. It had achieved the first of its goals: put a man in space. Now things would truly get going. On the schedule, do it again, and then go a little further. Space, then orbit, then beyond. Now that Project Mercury was fully in motion, what was the next move? After one successful suborbital flight, the plan was to make sure they didn't just get lucky and do it again. Mercury-Redstone 4 was to be a complete repeat of Mercury-Redstone 3, a suborbital crewed flight to the same apogee of 116 miles or 187 kilometers. The pilot was to be Virgil Gus Grissom, with John Glenn as the backup pilot. With the Soviets preparing to repeat the orbital flight of Yuri Gagarin with Vostok 2, which would launch at the end of August, the flight of Mercury-Redstone 4 was first planned for July 16th, then July 21st, 1961. Grissom named his spacecraft Liberty Bell 7, and, for an extra flair of creativity, gave it a white, irregular stripe of paint meant to imitate the crack in the Liberty Bell in Philadelphia. Officially named Mercury Capsule No. 11, the spacecraft was actually the first to come off the production line with a center trapezoidal window instead of 2 porthole windows as Shepard had flown on Freedom 7. No. 11 also had a feature that was entirely new, an explosive hatch release that would allow the astronaut to get out of the spacecraft quickly in the event of an emergency. This hatch release would later prove to make Liberty Bell 7 the first near miss in NASA's history of crewed spaceflight. To be honest, the hatch of the Mercury spacecraft could almost have an entire video itself, and because it was very key to this second crewed flight, let's talk about it a little bit. The original Mercury exit procedure which the crew had been trained on was to climb out through the antenna compartment at the top of the spacecraft. In order to do so, he would have to remove a small pressure bulkhead, making it a difficult and slow procedure. Concerned about possible emergency situations, it was believed that removing an injured or unconscious astronaut through this top hatch would be virtually impossible. The original side hatch was bolted shut with 70 bolts and covered with spacecraft shingles, making it equally slow and difficult to open. McDonnell Aircraft were tasked with coming up with a quick release mechanism, and they came up with 2. First was a hatch that used a latching mechanism, allowing it to open more easily, and were used on both the flight of Ham the chimpanzee on MR2 and Alan Shepard on MR3. However, the latch design was too much weight to use on the planned orbital version of the spacecraft, so a second design was introduced, an explosive release hatch. This design used the same 70 bolts of the original design to secure the hatch, but each bolt had a tiny hole bored into it, providing a weak point, A mild detonating fuse was installed between the inner and outer seal of the hatch, and when ignited, would create enough gas pressure to cause the bolts to fail and the hatch to blow out and away from the craft. The explosive hatch could be fired in two different ways. On the inside, there was a knobbed plunger. The pilot could remove a pin and then press the plunger with a force of 5 or 6 pounds, which would detonate the explosive charge, shearing off the bolts and propelling the hatch 25 feet away in 1 second. If the pin was not removed, the plunger could still detonate the charge, but would require around 40 pounds of force to do so. Additionally, on the outside of the hatch, rescue personnel could blow the hatch by removing a small panel and pulling a lanyard, similar to designs already existing on fighter jets. For the first two launch attempts, July 16th and July 18th, weather postponed the mission before Grissom had a chance to board the spacecraft. On July 19th, Grissom was on board and there was only 10 minutes and 30 seconds left on the clock when the flight was, once again, rescheduled to July 21st. On that morning, Grissom entered Liberty Bell 7 at 8:58 a.m., and the 70 hatch bolts were put into place. However, 45 minutes before launch, a hold was called when a pad technician discovered that one of the bolts was misaligned. During the 30-minute hold, McDonnell and Space Task Group engineers decided that the 69 remaining bolts should be sufficient, and the misaligned bolt was not replaced. At 12:20:36 UTC, Liberty Bell 7 lifted off of the pad.
Ignition. Liftoff.
Roger, this is Liberty Bell 7. The clock is operating.
Loud and clear, Jose. Don't cry too much.
Okie doke.
Immediately following ignition and liftoff, Grissom would later admit that he was a little bit scared, but felt his confidence build in parallel with the acceleration of the rocket. He was amazed with how smooth the liftoff went, but then noticed that, as it went along, he could sense more and more severe vibrations, though they were never violent enough to actually impair his abilities. He stayed calm and watched the instruments for the redstone, seeing the launch progress normally as his cabin pressure sealed off around him. As the rocket came close to finishing its powered flight phase, Grissom looked out the window and saw a sudden change in color of the horizon, from light blue to jet black. He was then distracted by the noise of the abort tower firing itself away right on schedule. He felt a thump as it separated and watched it through the window as it trailed off in a plume of smoke. At 2 minutes and 22 seconds after launch, the Redstone's engine shut down, and Grissom was disoriented for a moment, feeling like he was tumbling as he transitioned from high to zero gravity. However, he was back in control of his faculties well before the end of the 10 seconds between engine cutoff and separation from the booster. He felt another thump as the posigrade rockets pulled the spacecraft loose, and as the spacecraft turned around, he tried to get a look at the spent booster, but he was never able to see it. Much like Shepard's flight, now was the time to test out the manual controls. However, Grissom was a little busy staring out the window. He was fascinated by the sight of the Earth from space, and it took him several seconds to tear his eyes free and look at his instruments. When he finally made a pitch movement, he went past where he intended, and spent several seconds trying to correct this before making a yaw movement and doing the same thing. There was only a short amount of time the astronauts were safe to make these maneuvers, and because he had taken so long to do the first two, he omitted the roll movement. Now that the practice maneuvers were finished, he was free for a few moments to observe what he wanted, so he moved so that he could see the ground below him. He saw some land between the clouds, but he wasn't certain where it was, and then suddenly, the Florida Cape came into view with such clarity that Grissom could barely believe he was over 150 miles or 240 kilometers away from it.
I can see the coast, but I can't identify anything. Roger, 4+40, Gus.
He saw Merritt Island, the Banana River, the Indian River, and an airport runway. South of the Cape, he saw West Palm Beach. Gus Grissom was in full overview effect, in awe at the sight of the Earth from space, with its thin skin of atmosphere keeping out the rest of the cosmos outside. Around 5 minutes into the flight, it was time to prepare for re-entry. Grissom moved the capsule into the correct orientation with the heat shield facing forward and initiated the retro rocket sequence. When they fired, it gave him a strange feeling, as if he had stopped moving in the direction behind him and was now moving forward, though he was simply slowing down. A few moments after the retrofire completed, he saw two of the spent rockets pass across the periscope view as the package was jettisoned. Re-entry went smoothly as condensation and smoke trailed off the heat shield while the spacecraft plummeted back into the atmosphere. He saw and felt the drogue chute deploying at 21,000 feet, and then the main parachute at 12,000 feet. Grissom took a look as it unfurled, seeing two small tears in the fabric. They worried him, but everything stayed intact while he slowed down to splashdown speed. Grissom heard a clunk. The landing bag had dropped in preparation for impact. At this point, he removed his oxygen hose and opened his visor, but left the ventilation hose attached. Impact was unremarkable, feeling much milder than Grissom had expected, although he felt the spacecraft heel over in the water until he was laying on his side, though he believed that he had been upside down at the time. Gradually, the spacecraft righted itself, and as the window came above the water, Grissom activated the rescue aid switch. Liberty Bell 7 was complete, and now was the point where it begins to get interesting. Gus Grissom prepared to be recovered, disconnecting his helmet and neck dam. Recovery helicopter pilot James L. Lewis, who was then around 2 miles away, radioed Grissom and asked if he was ready for pickup. Grissom replied that they should wait 5 minutes because he wanted to record his cockpit panel data with a pencil and paper, which took some time in the gloves of his pressure suit. After he had logged the data, he told the helicopters to approach for pickup, then removed the pin from the hatch cover detonator and laid back in his seat. In his own words, "I was lying there, minding my own business, when I heard a dull thud. The hatch cover blew away, and Liberty Bell 7 immediately began to fill with water and sink." Having unbuckled himself earlier, Grissom quickly removed his helmet and grabbed the instrument panel, using it to hoist himself through the hatchway. The co-pilot of the recovery helicopter, preparing to cut off the spacecraft's antenna whip with a long pole, watched the hatch cover fly off, strike the water 5 feet away, skip over the waves, and then see Grissom crawl out and swim away in a hurry. Believing the pilot to be safe and in good shape at this point, James Lewis quickly maneuvered his helicopter to try and recover the sinking spacecraft. They went so low that the helicopter's wheels were in the water as they threaded a hooked pole through a loop at the top of the craft. The capsule then sank below the water, but the cable attached to the pole went tight, indicating that they were holding on to it. Just as they moved to throw Grissom a personnel hoist, Lewis called a warning that the helicopter's engine was in danger of failing due to the strain of holding the capsule. Grissom, having swam over to try and assist, saw that the capsule was attached properly and looked up for the personnel line. Instead, he saw the helicopter start to move away. Around this time, Gus Grissom started to feel afraid. He realized that he was not riding as high in the water as he had been earlier. Air in his pressure suit was escaping through the neck dam, and the more air he lost, the less buoyant he became. The second recovery helicopter was moving in, and the water washed around by its rotors was clashing with that of the other helicopter, making swimming very difficult. He was angry and scared, looking around desperately for help as his head went beneath and above the waves. As the second helicopter came closer, he saw the face of pilot George Cox. George had retrieved both Ham the chimpanzee and Alan Shepard on the first Mercury flights, and the sight of them now calmed Grissom down somewhat. George tossed the horse collar lifeline straight to Grissom, who quickly wrapped himself into it, backwards. He decided very quickly that he didn't care, and was lifted out of the water after swells took him below twice more. The first helicopter continued to attempt to raise the sinking Liberty Bell 7. With the capsule weighing well over 5,000 pounds with all of the water in it, the helicopter was struggling to raise it high enough to drain the water from the impact bag. Like an anchor, it prevented the helicopter from moving in any direction except up or down. After a few attempts to bring it clear of the water, Pilot Lewis decided that he didn't want to risk losing 2 crafts in one day and cast loose, allowing Liberty Bell 7 to slowly sink beneath the water. Aboard the nearby aircraft carrier, Rear Admiral J.E. Clark noted that the depth of the area the spacecraft was sinking into was 2,800 fathoms, 5.1 kilometers, or 3.2 miles. A fair amount of controversy followed the flight and sinking of Liberty Bell 7. Gus Grissom maintained that he did not manually activate the hatch cover detonator. An independent review of the incident raised doubts that Grissom had blown the hatch, and it seemed that the astronaut office didn't believe he had done it either, as he maintained his position in the prime rotation spot for future flights. Everybody liked Gus and wanted to believe him, but there was a lack of explanation as to what had caused the hatch to blow that left a shadow of doubt around him. Until 3 Mercury flights later, when Wally Schirra stepped up to the plate to prove for a fact that Gus was innocent. Sigma 7 was sitting on the deck of the recovery ship after its flight. Schirra was still inside, asking to be towed to the ship rather than climb out while he was in the water. As it sat there, all of a sudden, the explosive hatch of Sigma 7 was blown. Schirra climbed out and showed everyone his right hand. As he had expected, the kickback from the manual trigger left Schirra with a visible injury to his hand, something Grissom didn't have. In a 1965 interview, Grissom speculated that the hatch had actually been blown by the external lanyard, as it had only been held in place by a single screw. Decades would pass before Oceaneering International, an engineering and applied technology company based out of Houston, set out to recover the sunken Liberty Bell 7. Kurt Newport, head of the team, found the spacecraft in 1999 after 14 years of scouring 24 square miles of open ocean. They first used sonar, mapping out potential targets over a period of weeks. Finally, when they were able to send a robotic craft down to investigate the targets, they found it after checking out the very first one.
Boy, that's got some height to it. Oh my God. This is it. I don't believe it.
I was supposed to go call some friends at 8 o'clock.
This never happens.
Oh, yeah, it does.
It never happens
Sure
to
it
me.
Their first attempt to raise the craft encountered a problem with its cable system, which snapped after hours of attempting to repair it, leaving their robotic craft down there with Liberty Bell 7. When they returned for another try, it took several more days to reacquire the spacecraft's exact location. They then had to establish the status of the depth charge the craft had been equipped with, designed to help locate it if it ever sunk. It had never gone off, so it took some time to figure out whether or not it was still a danger. Finally, on their second attempt, Liberty Bell 7 was successfully raised to the surface, cleaned up, and now sits in the Cosmosphere in Kansas, in remarkable condition for something that spent 39 years at the bottom of the ocean. Virgil Grissom remained a prominent figure in NASA, becoming their first astronaut to visit space twice when he flew the first crewed Gemini mission back in 1965 alongside John Young. They would be the first crew to demonstrate that a spacecraft could alter its orbit with the use of thrusters, a key part of the technology and applications that would be needed to carry humans to the moon. In 1967, Gus Grissom was one of 3 crew members of AS-204, which was planned to be the first crewed mission of the Apollo program, testing the Apollo Command and Service Module in low Earth orbit and being launched on a Saturn 1B. He and his other crew members, Edward White and Roger Chaffee, were in their command module on the pad performing a launch rehearsal about a month before the launch date. Grissom, as well as the other Apollo astronauts, had voiced a lot of concern about the module beforehand, mainly surrounding the amount of flammable material in the cabin, which was filled with a pure oxygen environment. The crew were so concerned that they gave a parody crew portrait to Joseph Shea, who had given the spacecraft a passing grade. Written on the other side of the photo was, quote, "It isn't that we don't trust you, Joe, but this time we've decided to go over your head." Frustrated with the slow rate of changes to the spacecraft to fix its glaring issues, Grissom took a lemon from a tree by his house and hung it on the Apollo simulator. Sitting in the capsule, the astronauts were waiting for mission control to troubleshoot a severe communications problem and running through their checklists again. Suddenly, a momentary increase in voltage from an AC bus triggered a spark and then a fire. The astronauts were heard exclaiming that there was a bad fire and that they needed to get out, but they couldn't. The fire had caused a dramatic increase of pressure inside the cabin, and as a result, the astronauts couldn't pull the hatch open. They were trapped inside, and all 3 perished. Apollo 1, as it was named after the fact, would stall crewed Apollo flights for nearly 2 years while the incident was investigated and a complete redesign of the Apollo spacecraft was ordered. When Apollo did finally land on the moon, everyone would agree that it had only been possible through the tragic sacrifice of Ed White, Roger Chaffee, and Gus Grissom, the second American in space. Despite a few hitches here and there, Project Mercury was progressing smoothly. With 2 suborbital flights under their belt, NASA was ready to move on to the next phase, putting an American into orbit. While the Soviet Union had effectively killed 2 birds with 1 stone with Vostok 1 and achieved crewed spaceflight and crewed orbital spaceflight in the same mission, NASA's program was more incremental, mostly due to the way the Mercury spacecraft was altered throughout the course of the program. The capsule that Alan Shepard rode into suborbit would be very different from the one Gus Grissom rode into suborbit, which would be very different from the ones that would go all the way into orbit, although on the surface, they all look quite similar. Moving on to orbital flights meant changing the launch vehicle as well. The Redstone booster, being modified from a short-range ballistic missile, was far from capable of placing anything into orbit. The vehicle to perform that job was the Atlas booster, which was derived from an ICBM, making it much more powerful. Testing of the booster dated back to before the first crewed mercury-redstone flights, the 2 vehicles being developed in parallel to one another. Mercury-Atlas 1, launched in July of 1960 with an uncrewed capsule, failed 58 seconds into ascent. As it wasn't visible above the cloud cover, it was difficult to determine what had happened from telemetry alone, though it was clear that the vehicle had broke apart from some amount of stress on it. This led to modifications to strengthen both the spacecraft and launch vehicle, as well as to use a more shallow ascent path to reduce the bending stress. Mercury-Atlas 2, launched in February of 1961, went much more smoothly, bringing Mercury spacecraft number 6 to an apogee of 183 kilometers or 114 miles, and to a speed just a few hundred miles per hour short of orbital velocity, intended to test the spacecraft's capabilities of re-entry. Reportedly, when the booster passed through Max Q, there was cheering in the control room that everything had held together through the most stressful part of ascent. Despite a bit of propellant slosh toward the end of ascent, all test objectives were met, But the next flight would not go so smoothly. Launched only 2 months later, Mercury-Atlas 3 was intended to put an uncrewed Mercury spacecraft all the way into orbit and incorporated a number of technical improvements on the booster. However, only a few seconds into the ascent, the vehicle failed to initiate a pitch and roll sequence, continuing to fly straight up into the air.
There she goes. Right about now. Right about now.
He looks good at first.
After 43 seconds, the range safety officer sent the destruct command, the launch escape system activated, and the booster exploded, raining down into the Atlantic Ocean. Investigations revealed an unknown fault somewhere in the guidance system, so the spacecraft itself that had blasted away from the explosion was fished out of the water and put atop a new booster for a new test. Upgrades to the MA-4 booster caused significant delays, dragging the launch date out to September of 1961. This one went far more smoothly, successfully placing the uncrewed spacecraft into low Earth orbit, a first for the Mercury program. Small concerns popped up here and there, including a failure of 2 thrusters that slowed Mission Control's ability to turn the capsule around for deorbit. However, since it achieved all of its stated objectives, Mercury-Atlas 4 would be the last uncrewed test flight of the system, so to speak. Mercury-Atlas 5 was marketed to the public as a demonstration of the safety of NASA's testing approach. Since they had only one successful Mercury-Atlas flight under their belt at this point, they stated that, quote, "The men in charge of Project Mercury have insisted on orbiting the chimpanzee as a necessary preliminary checkout of the entire Mercury program before risking a human astronaut." This was played to counter the Soviets' approach of one-shotting a man into orbit, painting it as reckless and lucky to have succeeded. NASA also worked hard to downplay the fact that in November of that year, a monkey died during an Atlas E launch failure, insisting that it was a different booster and was entirely unrelated to the Mercury program and this chimp's test flight. This test didn't go very well for Enos the chimpanzee, but don't worry, he came home safe and sound. Enos, much like Ham, the previous space chimp, was trained for the Mercury program for a long time before being selected for MA-5. It was similarly slow to prepare like the previous flight, taking a total of 40 weeks of pre-flight preparation, the longest in the program yet. Finally, on October 29, 1961, 3 chimpanzees were moved into quarters at the Cape to prepare for the flight. Enos, a name meaning man in Hebrew, was chosen as the primary candidate, and he had 4 backups: Dwayne, Jim, Rocky, and Ham, veteran of Mercury-Redstone 2. The plan for the flight was similar to this previous chimp flight, except that now the capsule would be placed into orbit. The spacecraft itself would be controlled from the ground, while the chimp in its enclosed capsule would be performing physical tasks in response to instructions in the form of lights. A bulb would light up above a switch, and if the chimp flipped the switch in time, they received a reward in the form of a banana pellet. If the chimp didn't respond in a timely manner, it would be given what NASA refers to as a, quote, mild electric shock as punishment. And this is when we remember that it's the early 1960s and animal rights are not quite what they are today. Enos and his self-contained spacesuit couch were placed in the spacecraft about 5 hours before the launch on November 29, 1961. Liftoff and ascent was nominal, launching the spacecraft into a 99 by 147 mile orbit, or 159 by 237 kilometers.
Now the countdown approaches 0 and blast off. History in the making.
Everything went exceptionally smoothly, that is, until the capsule was finally separated from the booster. On its first orbit, everything seemed relatively nominal, except that the capsule's clock had fallen out of sync and was reading 18 seconds too fast. A command was sent as it made its first pass over Cape Canaveral to correct it, and shortly afterwards, things began to go wrong. The MA-5 capsule was drifting. One of its thrusters that controlled roll had malfunctioned, causing the capsule to move away from its intended attitude. After a little while, the automatic stabilization system would fire thrusters and swing the capsule back in the right direction. Throughout this flight, this correction maneuver occurred 9 times, eating up a total of around 9.5 pounds of fuel, while the first orbit before the thruster failure used around 1.5 pounds for the entire circle around the Earth. Furthermore, in the middle of the second orbit, Mission Control began to notice that it was getting pretty warm inside the capsule. The temperature inside Enos's couch suit had gone from 65 degrees Fahrenheit or 18 degrees Celsius to 80 Fahrenheit or 27 Celsius. As Enos's temperature began to increase in turn with the suit, the medical observers became worried about the chimp's safety. However, by the time the spacecraft was above Hawaii for the second time, the temperatures had returned to normal and the equipment was functioning properly again. Enos was okay, but the attitude problems persisted, leading to the decision to cut the mission short. Intending to complete 3 orbits, the decision was made to begin the retrofire shortly before the end of the second orbit. Perhaps it was for the best, because during the flight, a new problem arose that, to my understanding, Mission Control didn't seem to be aware was happening at the time. Enos was executing his tasks with a reinforcement system that gave him banana pellets for correct answers and gave him a little jolt for wrong answers. However, at some point, something broke. Despite continuing to perform correct commands, the system started to jolt Enos every single time. The number of times varies depending on the source. The popular lore is that 76 shocks were delivered and is backed up by a book called The Great Apes: A History by Chris Herzfeld and Jane Goodall. However, the only actual source from NASA that puts a number to it claims that number to be only 35. Regardless, the reinforcement system was shot, and Enos no longer had a way of knowing he was pressing the correct commands. He began to press all of them, one by one, testing his way systematically through all of them to find some kind of alternate solution. Finally, after receiving 35, or 76 depending on who you believe, shocks to his body, the switch returned to normal function, and Enos continued through the program. Mercury-Atlas 5 splashed down safely about 250 miles south of Bermuda. The spacecraft was picked up, placed on the deck, and the hatch was opened. Enos was recovered safe and sound, though he had removed all of his medical electrodes and his diaper. MA5 was a complete success, and it was time to put an American into orbit. A press conference was held in early December of 1961. Mercury-Atlas 6 was announced, the first crewed orbital spaceflight in the U.S. space program. The prime pilot was John Glenn, and Scott Carpenter was his backup. At the same time, they announced Mercury-Atlas 7, with Deke Slayton and Wally Schirra as pilot and backup respectively. Among the largest changes to the hardware of this flight was actually inside the cabin. Glenn had a small medical kit that had everything from morphine, shock symptom treatments, motion sickness treatments, and stimulants. He also had a survival kit with desalter kits, dye markers, distress signals of varying kinds, a small raft, survival rations, and a small radio. There was a lot of focus put on Glenn's safety, largely because the effect of an orbital spaceflight on human beings was completely unknown. The only people who knew were the Soviets, and they weren't sharing. Glenn also had a camera, a small 35mm film camera that he bought himself. He brought this along with some pushback from NASA. They feared that cameras might prove to be very distracting for the astronauts. With an initial launch date of January 16th, MA6 was postponed several times until February 20th. There were a mix of reasons. In addition to a fuel leak causing 2 weeks of repairs, bad weather kept getting in the way. Mercury-Atlas 1 had failed somewhere above the clouds, and nobody had been able to see what happened, so NASA's policy became to launch only in clear skies. At the same time, they also needed to keep the anxious public as happy as possible, so they kept emphasizing the need for a high degree of preparation and safety standards for this first crewed orbital spaceflight. John Glenn climbed aboard his spacecraft, which he had named Friendship 7, on February 20th, 11:03 UTC. The hatch was bolted in place, twice after one bolt was found to be broken, and the entire process was repeated. After 2 hours and 17 minutes of holds, Mercury-Atlas 6 roared into the sky, Glenn's pulse climbing to 110 beats per minute.
10, 9, 8, 7, 6, 5, 4, 3, 2, 0.
After some pretty high vibrations through max Q, the flight smoothed out, and staging as well as tower jettison was nominal. When the sustainer engine cut off, Friendship 7 was safely in orbit, only 7 feet per second below its intended velocity. The capsule was separated from the booster and performed its turnaround maneuver into the proper attitude. America was in orbit.
Roger, 0G, and I feel fine. Capsule is turning around. Oh, that view is tremendous.
The first orbit was mostly nominal and uneventful. Glenn saw the sun set from orbit, saw a dust storm in Nigeria, and the lights of Perth, Australia. As the sun rose over Australia, Glenn was momentarily taken aback when he suddenly found himself completely surrounded by a field of tiny glowing specks, something he called fireflies, floating around outside the capsule. Quote, "I am in a big mass of some very small particles. They're brilliantly lit up like they're luminescent. I never saw anything like it. They round a little. They're coming by the capsule and they look like little stars. A whole shower of them coming by. They swirl around the capsule and go in front of the window and they're all brilliantly lighted."
Roger, Ship 7, we'll give blood pressure check. I still have some of these particles that I cannot identify coming around the capsule occasionally, over.
Roger, how big are these particles? Over.
Very small. I would indicate they're of the order of a 1/16 of an inch or smaller. They drift by the window, and I can see them against the dark sky. Just at sunrise, there were literally thousands of them. It looked like just a myriad of stars, over.
It was later determined that these were bits of ice crystals that formed and then broke off the spacecraft, winking in the rising sun around him. Shortly before the second orbit began, problems with the stabilization system began to arise. A yaw thruster was malfunctioning. Glenn tried different control modes to figure out the most fuel-efficient way to keep the spacecraft steady, and 20 minutes later, the yaw thruster began working again. After switching back to automatic control, the opposite yaw thruster malfunctioned, causing Glenn to leave the spacecraft in fly-by-wire mode for the remainder of the flight. However, the problems were far from over. Don Arabian, Flight Systems Controller, made a note of a strange reading regarding the spacecraft's landing system. As Friendship 7 passed over Cape Canaveral at the beginning of its second orbit, John Glenn was asked to check the landing bag deploy switch and verify that it was in the off position. Glenn confirmed that it was, and then became suspicious when the next site he passed over made the same request, then the next site. He was right to be suspicious. According to the data being received by Mercury Control, the heat shield and landing bag were no longer in the locked position and only being held against the spacecraft by the straps that held the retrofire package. While Mission Control tried to figure out what to do, Friendship 7 passed over the Indian Ocean, where a tracking ship was being buffeted by a heavy storm. Originally planning to release balloons to see if Glenn could see them, the ship instead fired flares up into the air. Glenn couldn't see them, though he could see the flashes of lightning from the storm they were experiencing. One last problem arose during the second orbit. Glenn's spacesuit was too warm. Beginning as he had passed over the Canary Islands, he finally tried to adjust it while he flew over the Indian Ocean. By the time he reached Australia, a signal light warned him that the cabin was getting too humid. All the way to splashdown, Glenn would have to carefully balance keeping his suit cool and keeping the cabin from filling with condensation. Glenn flew his third orbit without any major issues. The entire time, Mission Control was monitoring the problem with the landing bag. Over Hawaii, Glenn was asked to toggle the deploy switch into the automatic position, hoping for a light to come on. It didn't, and Control was left undecided on what to do. Leave the retrofire pack on as a retainer, or jettison it in the usual planned manner. Eventually, the decision was made to leave the pack in place during re-entry until the spacecraft was over Texas. 4 hours and 33 minutes after launch, Friendship 7 was nearing the coast of California, and John Glenn was preparing for atmospheric re-entry. The retro rockets fired, and Glenn had the same sensation as Shepard and Grissom that he was suddenly moving backwards, though he was only slowing down slightly. As the capsule began streaking through the upper atmosphere, with the pack still attached to the bottom, Glenn noted hearing noises that sounded like things were bumping against the capsule, possibly bits of the pack or the straps. He also noted that there was a, quote, real fireball outside, and even saw a strap from the retro package hang over the spacecraft window, consumed into ashes in the re-entry plasma. At peak re-entry heating, Glenn saw chunks coming off of something and flying by the window. He believed that the retro pack had been jettisoned at that point, and was worried that what he was seeing was his heat shield disintegrating. However, it was simply the pack breaking apart in the fireball. "I felt like a falling leaf," Glenn would later say, as Friendship 7 began to oscillate from side to side, making him unable to control it manually. He used the auxiliary damping system to stabilize it, which helped, but there was little fuel remaining from needing to correct the earlier yaw error. 51 seconds before the drogue chute deployed, the fuel ran out, and the spacecraft again began to sway around. Glenn contemplated deploying the drogue chute manually to regain stability, but before he could, the chute opened automatically at 28,000 feet. Glenn reported that everything was in good shape, and after the main chute deployed, he manually dropped the landing bag, which worked as normal. It never had become unsecured from the spacecraft at all. The reading at Mission Control was simply due to a bad sensor, and Friendship 7 splashed down safely about 220 miles northwest of Puerto Rico and 40 miles off from the planned landing zone. After being pulled onto the destroyer USS Noah, Glenn intended to leave the capsule through the upper hatch, but the heat was getting to him, and instead, He told the ship's crew to stand clear, and he blew the side hatch. The plunger's recoil cut his knuckles through his glove, a wound that Gus Grissom did not have if you recall the previous episode. As he got out and stood on the deck, Glenn stated, "It was hot in there." Project Mercury had achieved its goal, put Americans into space. All that was left now was to close out the remaining flights and move on to the next big leg of the space race. But we'll come back to that another day. Project Mercury had now achieved all of its goals, its entire reasons for existing. First, Alan Shepard and Gus Grissom had replicated the man in space part of the achievement. Then, John Glenn had matched Yuri Gagarin and put an American into orbit. So, what was next for Mercury? Honestly, not much. It was time to close out the program and prepare for Project Gemini, though these last 3 flights would not be without their controversies and quirks. Let's go through them one by one. So, Project Mercury has essentially caught up with the Soviet Vostok program, though the Reds still have a little bit more flight time under their belts. What was the next step for Project Mercury following John Glenn's first orbital flight? Well, do it again. Much like Gus Grissom's suborbital flight followed Alan Shepard's, the next orbital flight was intended to prove that the first time around was not a stroke of luck. Remember that the whole vibe around Mercury was to display NASA as the slow and steady tortoise that wins the race, while the Soviets were charging ahead with reckless abandon. NASA wanted to be seen as making sure that they were doing things safely and properly, while the Soviets were risking lives. Mercury-Atlas 7 was slated to be, essentially, a repeat of Friendship 7. 3 full orbits around the Earth for a new astronaut in a Mercury spacecraft. Which astronaut? Well, that decision was up in the air for a little while. The original plan had been for Deke Slayton to finally fly on what he was going to call Delta 7, but that changed in early 1962, just 2 months before the launch. Way back when he had first applied for the Mercury 7, Slayton was found to have an erratic heart rate during a centrifuge training run and was sent to Brooks Air Force Base for further medical examination. There, he was diagnosed with idiopathic atrial fibrillation, a form of heart arrhythmia. At the time, he was deemed safe to continue flying. However, early in 1962, NASA Administrator James Webb opened an investigation into Slayton's condition. On March 15th, Slayton was medically disqualified for flight, though he was considered open for later Mercury missions if his health improved. Slayton did everything he could, abstaining from alcohol and cigars, exercising more regularly, but to no avail. NASA leadership would later consider his medical status to remain a risk, and he was removed from eligibility to fly any Mercury missions, the only one of the 7 who would never fly. At least not in this program. So, if not Deke, then who? Originally, Slayton's backup for Delta 4 had been Wally Schirra. However, because the disqualification happened so close to the launch date, the decision was made to instead give the flight to John Glenn's backup, Scott Carpenter. Leading up to Friendship 7, Carpenter had been training non-stop in case he needed to step in for Glenn, so he was considered the most ready-to-go astronaut at the time. Carpenter quickly renamed the mission Aurora 7, saying it stood for the, quote, open sky in the dawn, symbolizing the dawn of the new space age. Aurora 7 was the first Mercury flight with a special focus on science. Up until now, Mercury had been focused on getting the job done. Human spaceflight was a whole new world, so the point was to make sure it was a doable feat, that the crafts were sturdy, the procedures were effective, and the astronauts were safe. With Aurora 7, they were only on their 4th manned flight, but it was time to expand a little and prove that human spaceflight was not going to be a one-trick pony. Over the course of his 5-hour flight, Carpenter was scheduled to perform the first studies of liquids and weightlessness, do some photography of the Earth from orbit, and attempt to observe a flare that was fired up from the ground. The liquids experiment was rather unique. There isn't a whole lot of room inside the Mercury capsule, so there was a multicolored balloon within which was a glass bottle, and within the bottle was water, all housed within the antenna canister. Weighing only 2 pounds, the balloon was divided into 5 sections: uncolored aluminum, yellow, orange, white, and a phosphorescent coating that would be white during the day and blue in the darkness. It would be suspended from a 100-foot nylon tether from in front of the capsule, allowing Carpenter to observe how the liquid within behaved and how space affected the reflective properties of numerous surfaces. The nylon tether also included a strain gauge that would allow measurements of aerodynamic drag that the balloon was experiencing. Scott Carpenter entered his spacecraft at 4:43 a.m. on May 24, 1962. Like the others, he also had a breakfast of steak, eggs, toast, orange juice, and coffee, and was also subjected to a hydration regimen of water, juice, more coffee, and sweet tea prior to insertion in the spacecraft. After a 3-hour wait, Mercury-Atlas 7 blasted off at 7:45 a.m. Florida time.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
I feel the liftoff. The clock has started. Roger. Loud and clear, Gus. Roger, Roar 7. Stand by for the time hack. Roger.
Ascent was nominal, save for a small anomaly regarding a hydraulic switch that registered a loss of pressure. Other instruments verified the pressure to be fine, and the issue was later resolved by insulating the switches, which were close to the extremely cold LOX valves. Despite this, Carpenter reached orbit almost exactly within the intended parameters and began his mission. Carpenter was the first Mercury astronaut to consume solid food during a flight, rather than the paste given to John Glenn. The food was freeze-dried cubes in a plastic bag, and it didn't exactly go well. Possibly crushed prior to launch, the anti-crumbling coating on the cubes failed, resulting in a number of loose crumbs floating around the cabin. Carpenter was worried they would get sucked into intakes or present a possible choking hazard, though neither ended up being an issue. Nevertheless, the crumbs along with a melted candy bar caused Carpenter to decide to not touch the food after the second orbit, settling instead for a sugar capsule. As the sun rose for his final orbit, Carpenter accidentally made a discovery and solved a mystery from the previous flight. His hand bumped against the inside wall of the cabin, and the impact knocked loose a shower of ice particles from the side of the spacecraft. As they glinted against the dawn light, Carpenter realized that these were the fireflies seen by John Glenn. He banged his fist against the wall of the craft a few times, setting loose more particles caused by steam from the life support system condensing between the bulkhead and the heat shield, which would then freeze in the vacuum of space. Aurora 7's science experiments were a bit of a mixed bag. The balloon experiment, for instance, was essentially a failure as the balloon failed to inflate properly. Cooper's attempts at orbital photography were difficult, as thick cloud cover frequently obscured his view of surface features. Likewise, his attempt to view a flare fired up from the ground were also unsuccessful. However, a more passive experiment was successful. The Mercury spacecraft was capable, sturdy, and deemed able to undergo more intensive and lengthier flights. As he prepared for landing, Carpenter was momentarily distracted by the view out of his window, and began the sequence a little late. The spacecraft failed to hold its attitude, and while he tried to figure out what was wrong, he fell behind in his preparations and also accidentally wasted fuel from the manual control system, which he had forgotten to switch off. After activating the retro rockets 3 seconds late, Carpenter was significantly off course when he re-entered the atmosphere. He would end up splashing down 250 miles or 400 kilometers off from his intended landing zone, prompting an hour-long search by the recovery fleet and a series of news reports that speculated as to whether or not he had made it back alive.
The plan to jump the paramedics onto the scene would seem to indicate that there is some concern in Mercury control that communication will not be reestablished with the spacecraft.
While he was brought home without any issues, Flight Director Chris Kraft was very frustrated with Carpenter's performance. In NASA's 1989 memoir about Project Mercury, Kraft called the flight the, quote, most successful to date, except for some extra expenditure of fuel. However, in his 2001 memoir, Kraft stated that, quote, he was completely ignoring our request to check his instruments. I swore an oath that Scott Carpenter would never fly again in space. The chapter of the memoir detailing the flight was even titled The Man Malfunctioned. Carpenter was sidelined for future missions and, realizing he was no longer wanted as an astronaut, asked for a leave of absence in the next year. During this time, he trained for the Navy's Sea Lab program, which resulted in injuries that would guarantee he would be unable to fly in space again. He formally retired from NASA in 1967 and from the Navy in 1969. Was what happened to Scott Carpenter fair? That's a difficult question to answer and entirely a matter of opinion. Christopher Kraft defended his actions by pointing out Carpenter's virtually flawless training record and stated there was no reason for him to fumble the landing so badly. At the same time, this period at NASA was filled with tensions between the astronauts and the flight controller office, and there were hardware malfunctions at work that hadn't been identified and had contributed greatly to the increased fuel consumption. Either way, NASA was under a lot of pressure to perform, and the botched landing had resulted in a full hour of news reports that an astronaut might have died on the way home from space. They needed to act accordingly, and they did so. To make up for this, Mercury-Atlas 8 dropped the science goals to focus on endurance and pilot training. Wally Schirra was up to bat, naming his spacecraft Sigma 7 and planning to spend a full 9 hours in orbit. The flight was delayed by 2 weeks due to problems with the Atlas booster, and these problems would end up following the booster all the way to launch. Schirra was woke up to have the first astronaut breakfast to include fish, a bluefin tuna that he had speared himself the previous day. He entered the spacecraft at 4:41 a.m. on October 3, 1962, finding a compartment held a wrapped steak sandwich that had been left for him. Countdown proceeded nominally except for a brief pause to fix a radar tracking station, and launch occurred at 8:15 a.m., producing small issues almost immediately.
5, 4, 3. I've liftoff, clock is started. Fancy feels real nice. You put your gear pins for this flight? Yeah, I got the pins on my office wall. Altimeter's off the page.
The booster was rolling very slightly, caused by a misalignment of the main engines, but was kept on track by the vernier engines. Further into ascent, the sustainer engine had lower than expected thrust and was consuming more fuel than it should have been, due to a fuel leak somewhere within the system. Nevertheless, Sigma 7 entered orbit nominally, though slightly higher in altitude than had originally been intended. 3 minutes into the ascent, Deke Slayton cut into the capsule communications. "Are you a turtle today?" he asked. Schirra quickly switched to the onboard voice recorder, not wanting to broadcast the answer publicly. The mission transcript would simply state "correct answer recorded," and it is at this point that I will direct you to my Project Apollo iceberg and even give you the timestamp to figure out just what Deke was talking about there. The orbital portion of the flight was mostly nominal. Over the first orbit, Schirra felt overheated and spent the second orbit adjusting the cooling settings while Mission Control debated on whether or not to bring him home early. However, he did get it sorted out eventually. Later over Australia, he tried to witness a flare being fired from the ground, but just like last time, it was obscured by clouds. He was, however, able to see lightning over Brisbane. On his fourth orbit, he attempted to spot the Echo satellite that should have been passing below him, but he never saw it. After 6 orbits around the Earth, Wally Schirra returned home, his re-entry and landing going much more according to plan than the previous flight. He was recovered only minutes after splashdown, and as scuba divers moved in to help him out of the capsule, he made a request. Let him sit in the capsule and tow it to the carrier before he got out. A whale boat was sent and he was brought aboard a carrier 40 minutes after landing. He then made sure everyone was out of the way and blew the explosive hatch to let himself out. Once he got out, he showed medical examiners his arm, the bruising from the heavy ejector switch providing further evidence that Gus Grissom had not, in fact, been responsible for the sinking of Liberty Bell 7. At this point, the question of whether or not Project Mercury should continue was up in the air. Schirra's flight was virtually flawless, and the program had completed all of its goals. Mercury had effectively done all it could, and the next real strides in human spaceflight would only begin once Project Gemini, which was already in development, actually started. However, there was one milestone that NASA had yet to meet the Soviets on: flight duration. Every single Vostok flight, excluding Yuri Gagarin's debut mission, lasted for more than a day. So, to truly compete, Mercury had to perform a mission that lasted more than a day. Thus, Mercury-Atlas 9, or Faith 7, was officially greenlit. If it didn't go well, more missions were on the docket, including a 3-day return trip for Alan Shepard, a second for Gus Grissom, and a second for Wally Schirra. Gordon Cooper would be the final Mercury astronaut to fly, and the final astronaut to fly a mission completely solo in the history of spaceflight. The extended mission would have Faith 7 covering a much larger portion of the Earth, and as a result, support infrastructure was beefed up. 28 ships, 171 aircraft, and 18,000 servicemen would be ensuring one man's safety during his flight. The Atlas booster that was used sported several technical improvements, as NASA now had a high degree of confidence in this rocket. It had an enhanced propulsion system that was intended to provide more stable combustion, improved booster actuators, several internal improvements to the turbopumps, and more that led to Convair engineers referring to it as their, quote, best bird yet. Cooper's nickname of Faith 7 referred to the faith he had in both this new booster and in the Mercury spacecraft itself. On the morning of May 14th at 6:36 a.m., Gordon Cooper boarded his spacecraft to find a gift from Alan Shepard. Shepard hadn't had the new urine containment device on his flight, i.e. a diaper, and left Cooper a plunger on the seat with a note that said, "Remove before launch." Cooper, amused, did remove it, and then removed himself when the launch was scrubbed due to problems with both the radar in Bermuda and with the diesel engine that rolled back the rocket gantry. The next day at 8:04 a.m., Faith 7 lifted off successfully.
8, 7, 6, 5, 4, 3, 2, 1.
Roger, have a lift off and the clock is operating.
Roger clock.
Sigma 7, Phase 7 on the way.
A few very minor anomalies were automatically corrected by the improved booster, and orbital insertion was perfectly nominal. By the third orbit, Cooper began to look at his list of 11 experiments. One of these was to repeat Aurora 7's balloon experiment. However, after several attempts to eject the balloon, it simply wouldn't deploy. As it was attached to the parachute compartment, the cause of the failure would never be revealed, the entire experiment destroyed when the spacecraft landed. Another experiment involved deploying a 6-inch sphere that had been equipped with strobe lights, a test of his ability to track a beacon in orbit. After deployment, Cooper couldn't see it, but did spot it on his fourth orbit, remarking that, "I was with that little rascal all night." At orbit 9, Cooper was go to take a rest. He enjoyed a dinner of powdered roast beef mush and water, and reported that he was not sleepy, and instead took the time to do what he believed was his best orbital photography of the mission, specifically those over the Tibetan Highlands and the Himalayas. On the 17th orbit, he achieved a worldwide first when he transmitted live SSTV footage of himself inside the capsule, though the quality was obviously less than stellar. By the 19th orbit, the spacecraft began to experience a rapid series of technical difficulties. First, a faulty indicator read that the craft was starting to experience 0.05 Gs, though of course it was still in a stable orbit and this was not true. On the next orbit, all attitude readings failed, and on the one after that, a short circuit left the automatic stabilization and control system without power. On orbit 21, John Glenn relayed a revised checklist for retrofire to Cooper, mostly consisting of steps that would now have to be done manually rather than automatically. The deorbit and re-entry process went completely flawlessly, and Faith 7 splashed down only 6 kilometers from the recovery ship, the most accurate landing in the entire program. After getting out of the craft and being examined, it was found that Cooper was mostly healthy, though a little dehydrated and stiff from sitting in the cramped capsule for over a full day. Following this, there was another brief discussion about whether or not Project Mercury should continue with one more flight. The next planned one would last an unprecedented 3 days, with Alan Shepard returning to flight after his first suborbital hop. However, Project Gemini was calling. It had new goals to expand the capabilities of human spaceflight, including spacewalks, 2-man crews, and performing orbital rendezvous and docking. Project Mercury had achieved its goals by doing everything that the Vostok program had done. The Soviets were still winning in terms of pure flight time, but this was a milestone that NASA decided that they could afford to miss. Project Mercury was complete. NASA's first crewed space program was far from perfect. It existed in unprecedented territory and called for new techniques and hardware that had never been seen before. It was a little janky in a lot of ways, employing existing technology instead of wholly inventing new ones. Early capsules were delivered on top of mattresses on simple flatbed trucks. The launch tower was a repurposed oil derrick. Vehicles were weighed using a truck stop scale. Fire suppression water cannons were manually operated. The azimuth of each launch was changed by a person physically going out and moving a ring that the rocket was sitting on. With all of this improvised infrastructure, engineers were trying to account for the unaccountable, conceive of problems that had never been experienced, and keep people safe in unparalleled, extraordinary circumstances. Astronauts and engineers were put in danger constantly. One nearly drowned, another nearly burned up on re-entry. But Mercury came out of it with a completely unscathed legacy. What it is known for today is, despite never beating the Soviets to any punch, matching them on every effort, often very shortly afterwards. It established all the ground rules. Mission Control crafted their rules around Mercury and continue to live by them to this day. The best of the best, and a couple of chimpanzees, were blasted off the Earth riding in cramped tin cans that sat atop repurposed weapons of war to explore space and come home in one piece. There were those who said these days would never come, that man would never fly safely in space, that what the Russians were doing was a gimmick and it would pass. But look at all that stands on the shoulders of Project Mercury. Today, if you're at the right latitude, on many nights you can go outside and watch a light move across the sky. The light of a permanently occupied research laboratory that has been working in space for over 20 years. We can look at the existing and upcoming achievements of the new space age: Starship, Falcon 9, New Glenn, the Artemis program, and eventual boots on Mars, and know that we owe it all to 7 hardened test pilots and the many hard-working, brilliant people who stood behind Project Mercury.